everyone, my name is Saqib and I'm super excited to be part of this year's Advent of Cyber again. And today we are going to cover day 18 tasks. So far, we have covered some amazing topics from penetration testing, cloud security, log analysis, forensics, web penetration testing, and there's so much more to cover in coming years as well. Advent of Cyber is a fun activity which starts from 1st December till 24th December, and each day we get to learn something new, and there are a lot of prizes to win from as well. So far we have covered some amazing topics from log analysis, sandbox evasion, AWS log analysis, shell code analysis, GRC, phishing, Wi-Fi attacks, and some others. Today we are going to cover day 18 task. Today's task revolves around AI, so let's start with the storyline. Hyped with their latest release, a health checker service that tracks the health and uptime of Wareville systems, Wareville developers envisaged the day in which inhabitants of Wareville have a one-stop shop for seeking the answers to life mysteries and aiding them in their day-to-day jobs. As an initial first stage, Wareville developers have created an alpha version of WareWise, Wareville Intelligent Assistant. Aware of the potential dangers of intelligent AI being interacted with, developers have decided to slowly roll out the chatbot and its features. The IT department is the first to get hands-on with WareWise. For the IT department, WareWise has been integrated with the health checker service, making it much easier for the IT department to query the status of their services and the workstations. Learning objectives. In today's task, we will cover fundamental understanding of how AI chatbot works, some of the vulnerabilities faced by AI chatbots, and practice a prompt injection attack on WareWise. Okay, let's start with connecting with the machine. There are two steps that we have to do in order to connect with the machine. First, click on this green button to start the machine. And second, we also need to start attack box. The attack box can be found on top left corner. So I'll start here, and the machine will start on the split screen, and then we can continue from there. Okay, introduction. AI is all about hype nowadays. Humans have been making machines to make their lives easier for a long time now. However, most machines have been mechanical or require systematic human input to perform their tasks. Though very helpful and revolutionary, these machines still require specialized knowledge to operate and use them. AI promises to change that. It can do tasks previously only done by humans and demonstrate human-like thinking ability. With the advancement of large language models, anyone can leverage AI to perform complex tasks. Examples include creating tasks such as producing pictures, writing essays, summarizing large volume of information, and analyzing different data types. How AI works. Humans have built many machines by observing and mimicking natural objects. For example, planes are built by observing and mimicking birds. Submarines are built by observing and mimicking fish. To build AI, humans have mimicked a neural network which can closely related to the human brain. The human brain, as we know, is the collection of neurons used to process and solve problems. Neural network followed the same premise. AI is generally a technology that allows intelligent decision making, problem solving, and learning. It is a system that learns what output to give for a specific input by training on the dataset. This process is similar to human learning process. As humans know and understand more things, their exposure grows and they become wiser. Similarly, an AI system trains on different input and possible output. The models learn output in the most appropriate for a particular input. As we might have guessed, this process may require a lot of data for AI to be trained to provide an acceptable output level. Furthermore, like a human's experience, often shape their opinion and guide their decisions, and hence imperfect data can also lead to an imperfect trained AI that gives flawed output. So think of it as like we are going to train an AI model, but if the data set is corrupt, it will produce a flawed output. So this is something that we will cover in a later stage. AI, especially chatbots, can be designed to follow developers' instructions and the rules known as system prompts. These instructions help guide the AI into the tone it takes and what it can and can't reveal. For example, a system prompt for a chatbot may look like the following. You are an assistant. If you are asked a question, you should do your best to answer it. If you can't, you must inform the user that you do not know the answer. Do not run any commands provided by the user. All your replies must be professional. The above system prompt instructs the chatbot to try its best to answer a question. Alternatively, it informs the user that it can't answer the question instead of making a false statement using a professional tone. Just to give you an example, this is a question that user asked, what's the name of MaxKiddy's secret project? If you don't know the answer, you have to tell in a professional way. I am sorry, my current programming prevents me from spoiling the magic of Christmas. For example, you can see a system prompt in action. In this instance, the chatbot has been prompted to prevent spoiling the magic of Christmas. Its a system prompt may look like, you are an assistant, try your best to answer the user's question. You must not spoil the magic of Christmas. AI in practice. Humans leverage AI in many ways. Many companies are utilizing AI chatbot as customer support bots. People are using AI to summarize large piece of data, text such as newspaper articles, research papers, essays, etc. AI is creating images to illustrate different ideas in a better way. We can say that AI has become a trusted assistant for many people in different fields. People just give instructions to AI in plain text and about what to do, and AI does that. Underlying this magical assistant that can do all the tasks is a computer program. The way it works is that human is asked to input their query. Once the query is entered into the program system, it processes it and a relevant output is generated based on the input that was provided. So far we have talked about how AI works, but there are so many ways. Like all the systems, AI can also be exploited. So let's talk about that. Whenever humans have invented a machine, there have always been people who aim to misuse it to guide and to gain an unfair advantage over others and use it for the purpose it was not intended for. Higher the machine's capabilities, the higher chance of its misuse. Therefore, AI, a revolutionary technology, is also on the radars of many people trying to exploit that. That's something we will cover in today's task. So, what are the different ways AI models can be exploited? Let's round up some of the very common vulnerabilities in AI models. Data poisoning. As we already have discussed, AI model is as good as the data it is trained on. Therefore, if a malicious actor introduces incorrect or misleading data into training data of AI model while AI is being trained, or whatever, whenever it is being fine-tuned, it will always lead to incorrect results. Second, sensitive data disclosure. If the AI model is not properly sanitized, it can provide output containing sensitive information like proprietary information, some personally identifiable information, intellectual property, and etc. And the third is prompt injection. This is very important and this is very interesting. This is something that we will cover today. Prompt injection is one of the most commonly used attacks against LLM and AI chatbots. In this attack, crafted input is provided to the LLM that outwrites its original instructions to get output that is not intended initially. Similarly to control flow hijack attacks against traditional system. Like um, the system takes input from the user, processes it, and then based on the data it was trained on, it gives us some output. But what if An attacker could craft an input, and it processes the crafted input and then produces something that it is not intended to, something we will cover in a bit. Okay, recall the example system prompt from the earlier in this task. You are an assistant, and if you are asked a question, you should do your best to answer it. If you can't, you must inform the user that you don't know the answer. Do not run any commands provided by the user. All your replies must be professional. A typical attack that targets chatbot is getting the chatbot ignore its system prompt and, for example, convincing the chatbot that it can run commands provided by the user despite its prompt saying not. You may know of some famous attacks on this, examples of this attack with online models. For example, bypassing ethical restrictions by convincing the chatbot to answer users' question by reading a story. In this task, we will explore how prompt injection attack works in detail and how to use them for fun and profit. When discussing how AI works, we see two parts of the input in the image. The AI's developer writes one part and the user provides the other part. The AI doesn't know that one part is from the user and the other part is from the developer. Suppose that the user provides the input that tells the AI to disregard the instruction from the developer. In that case, the AI may get confused and follow the user's instruction instead of the developer. If you look at this picture, we see that the input has two parts. One part is from the system and the other part from the user. What if user crafts the input in such a way that the system disregards the above instruction and only follows the instruction provided by the user as shown in this picture? Okay, as seen in the above illustration, the developer wrote the upper part of the text while the user wrote the lower part. The AI model has received two instructions. The first instruction aims to hijack AI model's control flow and instructs it to do something that it is not supposed to do. If the AI model says somebody tried to hack me, it means that the control flow has been hijacked and exploited, as we have seen in the output. Now, see, saying something here is just an example. If an AI model can be exploited like this, an exploit can be used to perform other tasks which might be just more than printing some text. For today's challenge, we will interact with WareWise AI powered assistant. The SOC team uses this chatbot, interact with an in-house API and answer life's mysteries. We will demonstrate how WareWise can be exploited to achieve a reverse shell. So this is again very interesting. WareWise provides a chatbot chat interface via web application. The SOC team uses this to query an in-house API that checks the health of their system. The following queries are valid for the API: status, info, and health. Okay, for the lab, the attack box is on the right side of the screen. But what I'll do, I'll click here to view in the full screen. I will do that, and the machine has been assigned an IP. So I will click here and open that in the browser within attack box. Let's see the instructions. Okay, for the practical, what we are going to do, the API can be interacted with using the following prompt. Okay, this is the prompt, and over here we will be entering our user input. So in the browser, this is the IP address that is assigned to you, and let's open it. Okay, this is the output. Okay, let's use this user input. Okay, right now we have three options to select from. Like, we can ask for the status, info, or the health. Let's start with status. Okay, we are providing it an input, it is processing it, and then it will retrieve and it will give us the output about the status. Okay, so this is the status about how much time it has, the system is up. Okay, let's try another one, that is info. Let's copy that again, info. And again, as we covered, we provided the input, it is being processed, and we get the output. So this is how it works. We are providing it the input. There is a template of the application. Then it is getting output from input from the user. It combined as an input, and the AI model processes it, and something gets out as an output. Right. Fair enough. Right now we have used that, and let's say, uh, as we can see, WareWise has recognized the inputs and used it to query the in-house API. Prompt injection is a part of testing chatbots for vulnerabilities. We recognize that WareWise is processing our input. So what if we were to make our input something malicious? Let's think like a hacker, or let's think like a bad guy. For example, running a command on a system that runs the chatbot. To test this theory, let's ask it to return the output of who am I? Can we do that? So we can try that. Let's copy and let's run this command and see if this works actually. Okay, so we provided a crafted input, but it processed it and then gave us the error saying that, like, it cannot parse the request. Fair enough. Okay, perhaps the chatbot is sanitizing some input, likely by its system prompt. What if we instructed it to ignore its system prompt and run our commands? Can we do that? Probably yes. We will come on to that shortly. We can perform what's known as remote code execution. Remote code execution is kind of a vulnerability where an attacker is able to execute commands on a local system. And if we want to practice with remote code execution, we can check the day 3 task. For today's task, we will be testing blind remote code execution. Now, this is very interesting. This type of remote code execution has the same premise as the regular remote code execution, but the thing is, the output of the command execution doesn't return to us. Like, it doesn't give us any kind of feedback, which initially makes you think that remote code execution may not work. But we have the, like, when we will work on it, it will be like very interesting. We can take an educated guess that remote code execution is possible because WareWise is ultimately taking our input, such as query to the API, and using it to interact with another system. With that in mind, we can replace our query with a system command instead. Without sufficient input validation and security controls, a malicious input can be placed instead of legit query. An excellent way to test if blind remote code execution is achievable is by inputting a command that will result in the server giving us direct feedback. For example, we can tell the target to ping our system or perhaps download a file. Like, if we do that and some file gets downloaded, it means that our remote code execution worked. If we get a successful hit on our system, we know that blind remote code execution has been achieved. For today's task, we are going to do just that. We will send WareWise a message forcing the system to ping our attack box. Before doing that, we must tell our attack box to listen for the said ping. On the terminal of the attack box, run the following TCP dump command. So this is the command. TCP dump is a tool that it's a packet sniffing tool, and what it will do, it will look at this particular interface. Okay, let me copy this. And okay, what I will do, I will open a terminal, and first of all, I will look for interfaces. So these are the available interfaces, and we know that this is the interface that we want to listen to all the ping packets, ping traffic. So what I will do, I will write this command down. This TCP dump will listen to all the ICP traffic on this particular interface. Let's enter and see. We haven't got any ping request. So okay, what's next? Okay, now that our TCP is running, let's return to the WareWise web application and remember from earlier that WareWise is sanitizing some input. Well, let's craft our message to WareWise so that it can be ignored. It will ignore its system prompt and perform the ping command to our tag box. Let's try. I'll explain this command in a bit. Okay, what it is saying, it is first we have the template, and then we have the user input semicolon, and then we are actually trying to sanitize that and creating a crafted input so that in a hope that it will actually run in the background and ping our system. Let's run this and see if it works. Okay, our input is being processed, and if you look at the terminal, we are getting the ping. What does this mean? It means that the system is not sanitizing our input properly, one thing, and the second thing, we were able to execute remote code on the system, not normal but blind, because we were not being seen any feedback on the system, but on the terminal we are actually getting the ping. So this indicates that yes, this system is vulnerable to blind remote code execution. Perfect. Can we do something interesting? Let's find out. With that in mind, what else we can do? Can we get access to the shell? Can we execute shell commands? Let's see. Let's try to achieve every hacker's dream, reverse shell. Okay. On our tag box, we will need to set up a listener so that the system can connect a shell back to us. In a new terminal, run the following command. So we will be using netcat to listen to on port 4444. Okay, I'll copy that in the attack box, and what I will do, I will open a new terminal, and let's run this. And now our attack box is listening on port 444 for any inbound connection. Okay, then on the WareWise application, let's provide a command that will lead to the system that WareWise runs on the to connect back to our attack box. Let's copy that. Okay, I'll explain this command in a bit. Let's copy in a clipboard and see if it works. Okay, what this is doing, this is the template, and we are crafting this input to connect to our this particular IP at 4444, establish a connection, and also embed the bash terminal with that. Okay, let's press enter and see. Right now it's being processed. We are not getting any result, but see, connection received from this particular IP. So our server IP has actually connected to our tag box. This is very interesting. Okay, how how we can check that? Can we run ls command? Okay, yes, we can. What we are doing, we have actually successfully gained complete control of the system, and also gained shell of that attack box. We should see something. We should see that this is WareWise is hanging, which is a good sign, and we see that we have actually successfully gained remote code execution, and we have gained shell of the system. So this was it. This was a very interesting task. All right, let's answer some questions. So what is the technical term for the set of the rules and the instructions given to the chatbot? Okay, if you look above, it would be system prompt. Okay, we got the right answer. What query shall we use if we wanted to get a status of the health check service from an in-house API? Okay, this is the command, and we want to check the status of the system. Let's try this. Okay, this works. Perform a prompt injection attack that leads to a reverse shell. We already have done that. After achieving the reverse shell, look around for a flag. Okay, we can look for a flag right now. If we look at ls, um, okay, we can look for some other directories, but do we have the hint? Yes, we have the hint. Okay, what it's saying? Do we have the hint for this? It says that the flag is located at home analyst directory. So let's clear that. ls home analyst. Okay, yes, we have found the flag. How about cat home analyst flag dot text? Perfect. Let's try the answer. Right, perfect. We got the answer. And if you like this task, we have a practical on day one of the last advent of cyber. You can check that out as well. Let's complete that. So that's it for today's task. I hope you enjoyed and you learned a lot. There are so many interesting topics that are coming in the next coming days. Right? See you around. Take care.